Yeah, Nehru jacket I think is totally appropriate here because it's a little too cold to just be in a shirt, and a little too warm to wear a full jacket. So that's just perfect. Okay, I'm not used to talking about myself, but Sharad really insisted that I talk about my personal experience. So I started getting interested in science and engineering when I was very young. My dad was an engineer. I never thought of myself as possibly becoming a scientist, although I aspired to become one. I had no idea how you become a scientist. I had no idea that you had to, go to a top school, do a PhD, etc. I went to high school. I was good at math and physics, but my math teacher in 12th grade didn't like me very much. And you kind of need your math teacher to like you if you want to get into the top programs, the top schools, the top scientific schools, either École Polytechnique or École Normale Supérieure or things like this. And I didn't think I was up for this. You have to go through 2 or 3 years of preparatory school, where you basically only study math and physics, nothing else. And then participate in a national competition, basically. And depending on your ranking, you can choose the school you go to. And so there was basically, I didn't like this idea, partly because I was interested in engineering and building stuff. And I thought just doing math and physics for 2 years before actually doing stuff was maybe not the most interesting thing to do. So I went to a school that takes right after high school. And those are not viewed as kind of the royal way towards success in France. So, it's like, not going to Harvard or MIT or Stanford or Yale or anything like this, but, going to kind of another school that's less well known. But I discovered a passion for research and science, so studied a lot of physics. My major was actually VLSI design, strangely enough. I did electrical engineering. But I did a bunch of projects with mathematics professors because I was interested in AI and fundamental questions in mathematics and logic and things like that. So a bunch of independent projects, and that gave me a taste for research. And I discovered that I really wanted to do research. I graduated and then told myself, I don't know how to go about it, but I really want to work on machine learning. It wasn't called machine learning back then. I had learned about the existence of the field by stumbling on a philosophy book, which was a debate between Noam Chomsky, the linguist, and Jean Piaget, the cognitive scientist. And they were debating the question of whether language is innate or learned. Piaget was on the side of learning, and Chomsky was on the side of no. Language is basically an organ in your brain that's hardwired. And I read this book, and I thought that it was a debate between various people on the team of both sides, kind of arguing against each other. And I thought what Chomsky was talking about was bonkers, like ridiculous. Basically, could not possibly be true. Because I thought that learning was really kind of an important component of intelligence. And then on the side of Piaget was this MIT mathematician called Seymour Papert, who was describing a model called the perceptron. I never heard of this before. We're talking 1980. I was in second year of engineering. And he was talking about a model that was capable of learning, a computer program or a system that was capable of learning, and saying it's a very simple system, but it's capable of learning surprisingly complex concepts. And I thought the idea that a machine could learn was incredible, and I didn't realize people had worked on this. So I started digging the literature on this and realized that all the literature was from the 50s and early 60s, and then all the research in this field ended in the late 60s. And it ended in part because of a book a mathematics book that could detail the theory of why those simple models really could not be scaled up to building intelligent machines. One co-author of that book was the same Seymour Papert. It was co-authored with Marvin Minsky, a legend in AI. And so I was surprised that this guy, 10 years later, in the late 70s, during this debate, was singing the praise of the perceptron that he had helped kill the entire field working on this. So I kept digging the literature, realized that nobody was working on this in France or anywhere. Maybe a few Japanese people, because Japan has an isolated ecosystem of research, and so they kept working on this, not caring about what the West was thinking on it. But the topic had become taboo in the West, and there was no funding for it, and nobody was working on it. And then I discovered also through a book, a little by accident, that there was a small group of people in Paris who had formed an independent lab. They were all professors in universities, but they had formed an independent lab that was basically occupying empty offices in the Ministry of Industry in Paris. And those guys were interested in what they called at the time automata networks. So basically the idea that you can interconnect simple elements and you can have emergent properties out of a complex or large network of simple interconnected elements. The idea that they can self-organize. It's an idea that goes back to the 1950s of self-organization. The idea that systems can spontaneously organize themselves and produce complex behavior. And the brain, of course, is a perfect example of this. I was fascinated by that concept and thought that I really wanted to do research on that topic. So I talked to them, and they were not working on neural nets because I was in the field, but they told me, you should sign up for this graduate program and then work with us. And so I did. I worked on neural nets. Nobody was working on this, but they were, and I had to find an advisor. So one of the members of that lab was a full professor, so he could officially advise PhD students. And I asked him, can you be my advisor? I don't need any funding because I had funding from my engineering school. I had some sort of fellowship. But I needed a full professor to sign the papers. And he said, you seem smart enough. I'll sign the papers, but I have to tell you, I can't help you at all, like from the technical point of view, because I have no idea what you're doing. But I'll sign the papers. And so I did my PhD without talking to an advisor, basically. He was a very nice guy. He started working on neural nets after I graduated. Because, my PhD thesis, became a little famous, basically the first document in French with kind of a review of neural nets at the time. And so people assumed that he was working on this, and they applied to work on PhD with him because, he was kind of working on this. So we ended up working on neural net for quite a while afterwards. But I didn't have really a famous advisor. I didn't come from a top school. But I was convinced that some ideas were really important. The ideas that artificial intelligence had to be built not by engineers who design intelligent systems. I didn't think I was smart enough to design an intelligent machine. I thought the only way to get to this was for machines to design themselves using learning. And you see this in biology. Every biological system that has a nervous system can learn or adapt. Then I got to meet people like Jeffrey Hinton, Terry Sanofsky, and a few other people in 1985, and realized that there were other people in the world who were interested in the same question I was interested in. So this was the nucleus of sort of a new community, if you want, in 1985 or so. I graduated in 1987, and Jeff Hinton was moving to University of Toronto, and he told me, you can come in my lab, and I'm starting a new lab in Toronto and be a postdoc. But in 1985, I also met at a workshop a bunch of people from Bell Labs. And there's a story I need to tell there. I don't want to bore you with this, but it's a funny story. There was these two guys from Bell Labs, and there was a young guy that looked like a cowboy from Arizona. He was actually from Arizona. And he had big sideburns. He was wearing a jeans jacket and jeans. He had like cowboy boots and everything. And he was a young guy. He had just been hired at Bell Labs, a young scientist. He was a physicist from this PhD at Cornell in physics. And every single talk during the workshop at the end of the talk, he would raise his hand and ask a very nasty question, destroying the main point of the talk that was given. And regardless of whether the person giving the talk was a Nobel Prize winner or a Turing Award or whatever, they were like very senior, very reputable people giving this talk, and this young kid, 27-year-old or 28-year-old or something, raising his hand and basically telling this guy that he was an idiot. And so I turned to my colleague and asked, like, who are those guys? And they say, oh, they are from Bell Labs. Whenever you give a talk in front of Bell Labs people, they tell you, first of all, it was done at Bell Labs 10 years ago, and second, it doesn't work. Okay, and then I had to give a talk in front of that crowd, and there were very famous people. People like John Hopfield, who just won the Nobel Prize in Physics, was in the audience. Scott Kirkpatrick, who invented a technique called simulated annealing. One of my heroes in France was a very famous neuroscientist in France, Jean-Pierre Changeux. And then a whole bunch of people, very famous people. I was absolutely terrified, but I was particularly terrified of this guy. So I give my talk in very broken English. That was the first talk in English that I ever gave. And talking about multilayer networks, and people at the time were interested in what we now call Hopfield nets. Hopfield was in the room, and I thought that model was not very useful. I thought really to make progress in AI, you had to train neural nets with multiple layers. I was already obsessed with this back then. I'd come up with an algorithm to train them, which is very similar to what we now call backpropagation, although it was slightly different. It's closer to something we now call target propagation. But anyway, so I give my talk, and I assumed nobody understood what I was saying, which was largely true. And then this sideburn guy from Bell Labs raises his hand. And I literally liquefy, all my thing, right? So you've seen this movie, Amélie, right? There's a scene where she sees the guy she is in love with and doesn't dare talk to him, and she liquefies. Okay? That's what happened to me. So he raised his hand, and instead of saying something nasty, he said, I'm really happy to say this. You made me understand something I didn't understand. This is really cool. And I was like, what? 2 years later, they offered me a job. That's how I got hired at Bell Labs. By that time, they already decided they were going to hire me after I graduated. But I still had a couple of years to go. And then I did a postdoc in Toronto, and they held off because they don't want to poach people from academia. But when I was a postdoc in Toronto, they invited me to New Jersey, and I gave a talk, and they offered me a job. The story I just told is when I was in Toronto, they bought a new computer when I was there for the department. It was a Sun Microsystem computer called a Sun 4. This was kind of a new type of processors, and it was fast, and you could train neural nets, The thing was capable of maybe, a few hundred kiloflops. We're not talking even a megaflop. And when, a few months before I got at Bell Labs, my future boss at Bell Labs, department head, asked me, we want to buy a computer that, before you come, so it's ready when you show up. What computer are you using right now? I said, well, we're using the Sun 4 at University of Toronto. He said, okay. And then I show up at Bell Labs on my first day, and there is a Sun 4 waiting for me. And in Toronto, the Sun 4 was shared by 40 PhD students. I had one for just myself. So what's going on? And he said, at Bell Labs, you don't become famous by saving money. And I said, that's a great place. And the reason I joined, I didn't want to stay in North America. I wanted to go back to France. My wife wanted to go back to France. She was a pharmacist. And when I did my interview there, every project they were showing me around the lab at Bell Labs in Homedale were things that I read about in Scientific American or something like that. And I was incredibly impressed. A lot of that work that was shown to me actually was eventually was Nobel Nobel Prize winning work. There was a work on ion traps with lasers, laser molasses. 2 separate Nobel Prizes came out of that work from that little lab that was next door to our department. I was incredibly impressed by that place. I just could not refuse a job offer from Bell Labs. But I told them, I'm only going to stay 2 years. I need to go back to France afterwards. And in fact, after 2 years, I looked for a similar job in France. I worked for industry research lab at a company called Thomson CSF, which now has a different name. It's called Thales. And they had a central research lab near École Polytechnique in the southern suburbs of Paris. And I thought this was the closest thing I could find to Bell Labs in France. And I went there, but the Bell Labs people said, we keep your seat warm so that you'll come back. In fact, I had a deal which allowed me to be part-time at Thomson CSF and spend the summer at Bell Labs because I thought that was an incredible environment. And in fact, after 6 months, I went back to Bell Labs and didn't come back because the type of environment that I was finding there was no match in Europe that I could find. The companies I talked to in Europe, and this is relevant to the current situation in India, the companies that had research labs in France at that time were not as open, not as ambitious, not as visible, were largely more working on applied topics and not leaving a big leeway for scientists to kind of work on ambitious projects. It was maybe useful for their business, but really not, something that a young scientist with, some scientific ambition can aspire to. And so I went back to Bell Labs. My wife kind of gave up on her career and decided to have another baby. We never made the deliberate decision to actually stay in the US, but it just happened. And so I think there is some commonalities with what the current situation in India, which is that it's very difficult for young, ambitious scientists having graduated maybe from IIT on top of their class to do a PhD in India and stay in India and have some career prospect in India outside of academia. And going to academia is great, but it's not for everyone. Partly because of salary issues and stuff like that, which I'm sure are similar in France and the US and India, but also partly because of the environment that you have, and partly because teaching and the kind of environment that you have in academia is not necessarily for you. I didn't see myself as doing research in academia at the time. I never thought about the question before. So I didn't have similar opportunities as a researcher in France that I could have in the US in a place like Bell Labs. Of course, Bell Labs was a bit of an exception. There were only 3 or 4 labs in the US that had similarly ambitious, blue sky research. There was Bell Labs, IBM, Xerox PARC, and maybe a couple of smaller ones, maybe at General Electric at some point, and a few other places. But it was really limited. You could count those labs, ambitious research lab in industry, with the fingers of one hand. No opportunities in Europe, and certainly none in the 1990s, because most of those labs closed down, actually. So the reason I'm telling you this story in part is because if you want to attract young scientists, ambitious scientists, back in India, you have to give them career opportunities in industry. Most PhDs today in machine learning, AI, and computer science do not go to academia. Most of them go to industry. Some of them become entrepreneurs. Some of them become basically engineers or research engineers in industry. Some of them become scientists in industry. Many of them have a career path that starts with doing a PhD on theoretical stuff and then kind of going more into research that has some application component, but is still very much basic research, fundamental research. And then as time goes by, go into more and more applied stuff because they want to have an impact in the world. And then eventually perhaps start a company or become a head of an engineering organization or something of that type. And what I found in France is that in research lab at the time, if you spent more than 5 years as a research scientist in a research lab, you were viewed as having failed in your career. You were supposed to move out from the research lab and take an important position somewhere else in the company doing things that were more practical. So research was seen as a jump, a springboard, but not as a career. And I'm a scientist. I'm a researcher. I had many opportunities to kind of branch off and become an engineer or entrepreneur, and always chose to remain in science and publish papers and stuff like that. And so I think what India should strive to do is somehow create. There's already very good academic organizations that are high prestige, do fantastic research, but you need an industrial component for that, for people whose sense of innovation does not work in academia. And there's a lot of people like that who just, we hire them in research lab in industry. They don't have all the full-fledged, well-rounded personality that you need to be a successful academic, but they are really good at maybe a particular thing that make them really influential and productive in an industry environment, collaborating with other people, and etc. And so that doesn't exist in India. It did not exist in France when I was young. And after I joined Meta or Facebook and created FAIR, the research lab, I organized it so that this would be an organization of high prestige, an organization that was very ambitious, that would practice open research so that when you attracted a scientist to it, you could tell that scientist, your career as a scientist is not over. You can publish. You still have a name and a reputation. If 5 years from now you want to go to academia, you can, because you'll have a fantastic publication record. And there's no problem with this. And our ambition was to really produce absolutely top flight research and attract the best people, and it worked. And then after a couple of years, I figured that we should create a lab in Europe to basically take advantage of the incredible talents that are present in Europe. And the instinct for a Silicon Valley company is to open a lab in the UK because they speak English. The lawyers in California understand the laws in the UK because it's based on the same system, more or less. They understand the language. And there is a special relationship between the UK and the US. So that was the instinct. It turned out to be really difficult because DeepMind and Google viewed London as their protected backyard. And so they did everything they could to stop us. And in fact, it was pretty obvious pretty quickly. So I pivoted and convinced the leadership at Meta, Mark Zuckerberg, and the CTO, Mike Schroepfer, to actually open a lab in Paris. And the reason was that there was a high concentration of talents, and we were going to be the only industry research lab in Paris. And so we were going to be able to attract all the best people. And it worked. It was a complete success beyond our wildest dream. We indeed hired a whole bunch of really, really good people. We established this incredibly successful program of having PhD students in residence at FAIR Paris. And the existence of FAIR Paris gave a career opportunities for young, talented students in France. Now the coolest thing they could do, instead of going to work for a bank and do finance, was to actually do a PhD in AI. That was the best thing they could do, with the prospect, perhaps, of getting a job at FAIR in Paris, or maybe before that, of doing their PhD in residence at FAIR. So we got all the best students in France and more widely in Europe. We are actually graduating 12 students per year now at FAIR, every year. And those people go and basically pool the entire ecosystem in Paris. And I don't want to, Hervé, you can, Henri, sorry, you can tell me if I'm wrong, but I think the creation of Fair Paris was a key component of lifting the AI ecosystem in France to the point that now Paris is basically the hottest place outside the US for AI startups and AI science. So this had a huge impact. I think this type of effect can be reproduced in India. But what you have to do is give career opportunities for ambitious young scientists. All right, I've spoken too long. Thank you.